Josh is Captain Observation today. Yeah. That's angle B. And here is angle C. Angle C! Angle C. That says C. This is side A, side B, side. Ooh, that one kind of. Well, it's not. So anyway, that's a C. Anyway, so when it comes to trig, you cannot do trig unless you start at an angle. In this case, I'm going to start at angle B. I'm going to take sine of angle B, which means I'm going to go to angle B. What side, A, B, or C, is directly opposite of angle B? B. And which side is the hypotenuse? C. So sine of B is the opposite side divided by the hypotenuse. So sine of B equals opposite over hypotenuse. SOHCAHTOA is nothing more than ratios. One thing on top of the other. That's all it is all day. Cosine of B, notice I always say of B because if it was of A, it'd be different. It all depends on where you're coming from. Yes, I am. Cosine of B is the adjacent side, which basically means the side that it's touching that's not the hypotenuse. So the adjacent side over the hypotenuse. So cosine of B would be what? A over C. That's right. Tangent is the opposite side divided by the adjacent side. So tangent of B equals little b over little a. It's the side opposite the right angle. What? It's the side that it's touching that's not the hypotenuse. Okay, so like look at angle B. You see how it's formed by two sides? The adjacent is the side that it's actually made up of that's not the hypotenuse, so the other one. Exactly. Hence the A over C, adjacent over hypotenuse. Questions on that? Good. I'm hoping most of you guys remember that from geometry and potentially algebra, algebra and trig if you took it. There are three more. There are cosecant, secant, and cotangent. And they are nothing more than, now I'm going to write it as 1 over. But cosecant is nothing more than 1 over sine. Secant is nothing more than 1 over cosine. And one guess about what tangent, cotangent, forget it. There we go. 1 over tangent. Now when I say 1 over, CSC, cosecant. When I say 1 over, let's say, for example, let's put in numbers. Let's say sine of B was 8 over 17. Cosecant of B would be 1 over 8 over 17, which is essentially just flipping it. So it would be 17 over 8. Today, when I ask you for all 6 trig functions, if you are given sine or cosine, cosecant and secant will be just literally flip those. And you've got same thing for tangent and cotangent. You just flip the fraction and you've got the other one. Sine goes with cosecant, cosine goes with secant, and cotangent goes with tangent. Questions about that? Yes. Now we're going to put that together with one other thing. I need everybody to get out the circle we drew in class the other day with all those angles on it. Yes, sir. Well, just watch for now. Okay. This is 4.2. That circle we drew the other day, we did all those major angles. Remember 30, 60, 90, 45? We went all the way around, and then we also labeled their radian counterpart. Remember, it was like 5 or 6, blah, 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 blah. All the way around. Does everybody have that out? I think there's something wrong with my throat. Every time I sneeze, I have to push my lungs back over, or it like really hurts. Is that weird? Is that bad? Like, after I sneeze or cough, it feels like someone's jabbed a knife in my throat. I can't swallow anything. But if I physically push, is it normal? So, if I physically push over, like, not whatever this is, I don't know biology, but like the little tube, there you go, windpipe, in my throat, I can breathe easily. You may have a broken neck. Okay, I'm no doctor. You may be pretty much dead already. All right. That was a dragon. Okay. Clearly. You obviously don't know much about dragons, Mary. Jeez. Okay. Now, another quick review point. There were two special right triangles back from geometry and algebra 2. Special right triangles. 30, 60, 90 and 45, 45, 90. Now, who can raise their hand and tell me, in a 30, 60, 90 right triangle, the hypotenuse was always what of the short leg? Double. That's right. The hypotenuse was always twice the short leg in a 30, 60, 90, and the long leg was always the short leg times what? Anybody remember? Way to be on top of the ball, Caitlin. That's right. It's always the square root of 3. Always. Now, today, we're going to be dealing with the unit circle. Anytime you hear the words unit circle, keyword is unit, meaning the radius is always going to be 1 unit. Now, imagine, well, we don't even have to imagine. Leading up to this, all day today, with our radius being 1 unit, that means our hypotenuse is going to be 1 unit. So, using the same thing, if the hypotenuse is 1 here, what is the short leg going to be? 1/2. Very good. And that makes the long leg 1/2 times the square root of 3, which is the same as the square root of 3 over 2. That is a principle we're going to need to keep all day today. We're going to get to that in just a second. We're going to get to that. It's okay. Now, look at that circle we drew the other day. What was the first major angle we drew? 30 degrees. It was a 30-degree angle, which is the same as pi over 6, right? Now, unit circle. Hypotenuse is 1 unit. I could now draw this as a little right triangle. You see that? You see? Now, in a 30-60 right triangle, with a hypotenuse of 1, so basically you're just going to be reading me these exact values, what's the short leg equal to? 1/2. So what's the long leg equal to? It's no longer 1. Radical 3 over 2. Very good. Now, imagine, for a second, imagine this whole thing was overlaid on a coordinate plane. Y-axis, x-axis. This comes off 1. So when I rotate this up, I want to know the coordinate of this point on the coordinate plane. Now, let me preface that by saying this coordinate right here was just 1, 0. It went over 1, didn't go up at all. What is this coordinate? Well, how much to the right did we come? Radical 3 over 2. And how much up did we go? 1/2. So that coordinate is radical 3 over 2, comma 1/2. What if I went to 60 degrees? Way up here. This is now a 60-degree angle. I'm going to kind of draw it over here where it's a little clearer to see. 60 degrees. 60, 30, and here's my angle. Right here. We'll call this the reference angle. The reference angle is the angle that connects with the x-axis. So, this is still 1. Now my short leg is this horizontal component, isn't it? Which has a measure of what? 1/2. Just like over here. Short leg is still 1/2. And the long leg is radical 3 over 2. Same thing it was back in our original example. The only difference is on this one, the short leg is the horizontal part, and the vertical part is radical 3 over 2. These are all coordinates. Now, what's the point of this? Here's what the point is. If I were to say, what is cosine of 60 degrees? You could always just come back to this and say cosine of this. Adjacent over hypotenuse. What's 1/2 over 1? Good gravy. What's 1/2 over 1? 1/2. You could easily just use SOHCAHTOA and find that for yourself. But I'm going to give you a unit circle that has all those filled in for you. And I'm just showing you where they came from. On the unit circle, these are giving you the trig functions all the way around. You said cosine of 60 degrees was 1/2. At 60 degrees, the x value is your cosine. The y value is your sine. What was sine of 60 degrees? Opposite over hypotenuse, radical 3 over 2. What if I said, what is sine of 30 degrees? Well, what was sine of 30 degrees? 1/2 over 1. Sine of 30 degrees, 1/2. What was cosine of 30 degrees? Radical 3 over 2 over 1. And over here, what was my x value? Radical 3 over 2. What do you mean? The y value will always be sine. The x value will always be cosine. Always. Yes. And the x value will always be cosine. Now, while you let that sink in for a second, I'm going to pass these out. This is essentially the same exact circle, except I went ahead and had all of them filled in for you, so you don't have to write all of it. You can use this on your test and such. Yeah. We took our knowledge of special right triangles. Remember the 2x, x, and x radical 3? Okay. Well, we applied that. If 1 is the hypotenuse, and it's exactly twice the short leg, then you can just cut it in half and get that it's going down. So we just used our knowledge of special right triangles to jump to the conclusions about what those sides are. Now, everybody look down here. We could easily, in about 10 minutes, go through every one of these and show that sure enough, the x coordinate is this, the y coordinate is this, by doing nothing more than this special right triangle stuff. All the way around. I'll get to that in just a second. I'm glad you asked. We'll get to that in a second. Now, there was another kind of special right triangle, and it was 45-45. Can anybody tell me, in a 45-45 isosceles right triangle, well, that's horribly drawn. Go away. Thank you. 45-45. In other words, it's isosceles. If these were x, does anybody remember what the hypotenuse was? Close. It was x radical 2. X times radical 2. Which means if this was 3, this would be 3 times radical 2. If this was 7, this would be 7 times radical 2. If we multiply by radical 2 to get from the leg to the hypotenuse, how do we go in reverse? Instead of multiplying by radical 2, you divide. Very good. So let's say, remember what did we say the hypotenuse is going to be all day today? 1. If this is 1, then each leg is 1 divided by the square root of 2, which any time today you have a radical in the denominator, you have to rationalize it, which basically means multiply the top and bottom by that radical, and it's radical 2 over 2. So, this is what this is, right? Well, you can't have a radical denominator, so you multiply the top and bottom by that radical, and you get square root of 2 over 2. So that's why I'm going to come up here and change this the square root of 2 over 2. Are you cold? No. Oh, you got to be kidding me. It's like 1,000 degrees in here. Okay, never mind. So, by that same principle, let's pick any other random angle. What about 225 degrees? You can look at your unit circle if you want to. 225, that was here on your unit circle. Now, you're going to use the reference angle to manually make this. You don't have to make these all day. I'm just showing you where they're coming from. If this right here is 180, right? And this is 225, what is this little reference angle right here? 45. A reference angle is simply, it is nothing more than the degrees between your angle and the x-axis. That's all it is. So, if I draw in my little right triangle, I know my hypotenuse is 1, and what did I just say were each of my legs? Radical 2 over 2, which makes this coordinate, now remember, it's on the coordinate plane. Left is negative and down is negative. So negative radical 2 over 2, negative radical 2 over 2. Look on your unit circle. Is that not what it says? Yes, it is. That's where they're coming from. They're just using special right triangles and overlaying it and using a constant hypotenuse and radius of 1. That's all it is. So, simply looking at this unit circle, I'm not going to ask you to derive these. Simply looking at this, Tyler Hale, what is cosine of 4 pi-3? Cosine of 4 pi-3. Give him the x value. Tyler pointed out to me. Where's 4 pi-3? What is cosine? -1/2. That's it. You just look at the x value. Joseph, what is sine of 7 pi over 4? Seven pi over 4, sine. Negative radical. Sine is always the y, cosine is always the x. They come straight off of here. Again, you could easily draw yourself the triangle, use the special right triangle stuff and figure it out like that in longhand, but this is just to save you that time. It's to say, don't bother working it out like this every single time. We'll just give you the main one. Tyler Versii, what is sine of 2 pi thirds? Radical 3 over 2. Dylan, what is cosine pi over 4? You got it. Radical 2 over 2. Any questions about where we're getting sine and cosine? All right, Adam, tell me if you can find 5 pi over 6 on the circle. Oh, stop. Stop. You found it. Okay? When I say give me cosine of 5 pi over 6, that means go to 5 pi over 6 and tell me what the x value is. In the little ordered pair. What's the x value? No, it's the negative square root of 3 over 2. Do you see that? That's cosine. The other one is sine. Sine of 5 pi over 6 would just be 1/2. You see that? Now look at your circle, you might notice, think of it in terms of quadrants. Back when you first learned the graph, you learned right was positive, left was negative, up is positive, down is negative. That's why everything here is positive, positive. Everything over here is negative, positive, left up. Everything down here is negative, negative, left down. And everything over here is positive, negative. Everybody see that? Now, before we even get into tangent, what if I ask for secant and cosecant? You just go to that angle and then give me the flip of it. So, for instance, if I said, Brayton, if I said, what is cosine of pi over 6? Well, yeah, what would cosine of pi over 6 be? Cosine, pi over 6. Radical 3 over 2. What is secant pi over 6? Just what's it? 2 over radical 3, which you'd have to rationalize. But as far as just finding it, that's all you have to do. Go to it, flip it. Secant is the flip of cosine. Cosecant is the flip of sine. So, if cosine was radical 3 over 2, I think we're done with the circle, then secant would be 2 over radical 3, which you have to rationalize, which means just multiply the top and bottom by your radical, and you get 2 radical 3 over 3. Just flip it. I have a song stuck in my head the last 2 days. I'll be playing it later. Believe it. Now, any questions about where we're getting secant and cosecant? Find their counterpart, flip it over. Tangent. Tangent. Now, again, yeah, we know tangent is opposite of adjacent. But remember, this is a shortcut page. On the shortcut page, tangent is nothing more of some angle theta than sine of that angle over cosine of that angle. You may want to write that down. Sine of an angle over cosine of that angle. 72 degrees. It is 12 degrees hotter here than it is in my house. 12 degrees. At 60. Oh, yeah. And it is freaking hot in there. It's freaking hot.
You're like what? Always covered up all the time.
No, he's hotter than I am. Whatever. Tell me. That's right. I said it. I'm burying things in the past. What? The military for the government. Okay, anyway. So, if I said, what is tangent? Tangent of 2 pi thirds. You would go to 2 pi thirds. What's my sine value there? Tangent of 2 pi over 3. Radical 3 over 2 And then what's my cosine value? Negative 1/2. So I'm going to divide that by negative 1/2. And you are going to have to do a little algebra here. Dividing by fractions is the same thing as what? Flipping and multiplying. So flip the second one. Now look, things cancel. And you're left with negative radical 3. So that would be tangent 2 pi thirds. It's just sine over cosine. And once you have tangent, to get cotangent, flip it. There. That's just theta. It's like what x was for algebra, theta is for trigonometry. Just a variable. Well, that was sine over cosine. And then you just flip the bottom one and multiply. Now, if you notice in the first quadrant, they've got all the tangents laid out for you. They tell you what it is. It wouldn't take you very long to go around and finish drawing it in, so you wouldn't have to look it up every time, but that's completely up to you. And then cotangent would just be the flip of that. It would be negative 1 over radical 3, which you'd have to rationalize. Let's look at some examples. Good idea. All right, we're going to come back to those first two. All right, this is just the unit circle. Excuse me? Oh, well, I'll tell you. What would tangent of 3 pi over 2 be? It would be sine over cosine. It would be negative 1 over 0, undefined. That's why. Okay. Same thing at the top. Tangent of 90 degrees, 1 over 0, undefined. All right. You can use your unit circle for this. They just went ahead and kind of gave you another unit circle, but just use yours. Sine of pi over 6. 1/2. Bang. 1/2. Write it down. Let's find a harder one. Find on the unit circle. Tangent of pi. Over here, pi. Your coordinate is negative 1, 0. Sine over cosine. So 0 over negative 1 reduces to 0. Cosecant of 7 pi over 6. What's that the flip of? Which trig function is cosecant the flip of? Sine. So find sine 7 pi over 6, and then just flip it. So would that be negative 1/2? Flip that over. Was that negative 2 over 1? Done. Yes. That's true. No. But mostly. Right? Okay. Now, let's take it. Sure. Well, is that much? This right here is kind of an abridged unit circle. So, like sine of 7 pi over 6, you find 7 pi over 6 in a unit circle, take your sine value, 1/2. Sine is the y, cosine is the x. Alright? I don't see any undefined ones here, but like if it had said tangent of 3 pi over 2, sine is negative 1, cosine is 0. Again, it's on your unit circle, and that would be undefined. Questions about this slide? Well, what if they weren't perfect little values for us? What if they weren't on the unit circle, so we didn't know the angle, but they still gave us a coordinate? If they give you the coordinate, then they've given you the trig values, assuming that you're on the unit circle, which this one is. This is a unit circle. Here's your little triangle. Remember, it'll always form with your reference angle right here. Even though this is the angle, you'll draw it like this. So here's your little right triangle, with this being your theta. You know, because it's a unit circle, that the hypotenuse is 1. This is your horizontal component. I know a negative distance doesn't make much sense, but just go with it. This is your vertical component. And they just want your trig values. They want all 6 trig values. Sine, opposite of our hypotenuse, 8 over 17. You don't actually have to do it trig-wise if it's on the unit circle. This is still sine. This is still cosine. So later, when you do these later, you don't have to draw the triangle. You can, but you're going to get the same thing. What's cosine of theta? Adjacent over hypotenuse. Negative 15 over 17, which was already in the x position. Good question. The x coordinate will always be the horizontal piece. The y-coordinate will always be the vertical piece. And even if it wasn't a unit circle, let's say we didn't know this was a unit circle, so we can't assume this is one. If you have two pieces of a right triangle, from what Tyler said before class about what he hoped the lesson was, how could you find the third piece? Pythagorean theorem. So even if it wasn't a unit circle, you could easily find the hypotenuse. And then, if it wasn't one, you would have to do SOHCAHTOA. You'd actually have to match up the pieces. But if it is one, you can just jump the gun and take the coordinate.
I don't understand
No matter where you draw this, no matter where your angle is, it's always going to connect your angle to the x-axis. Always. That's how you're going to draw it. So like here's my angle, connected to the x-axis, there's my theta. Yeah, I know. But you can't make a right triangle with this angle. So you just take this one. And that's how you do it. I know it's confusing, but you just have to think of it in terms of the reference angle. It'll always connect your terminal side to the x-axis. Shortest distance to the x-axis. Oh, good question. Your answer would look like this. You would need to write in all of, actually it tells me, nope, I'm just going to use theta. Tangent, cosecant, secant. That's the same reason in the last bunch of sections we've done. We've just put x equals. That's just our default thing to solve for. Same thing. When it comes to angles, you just usually go with theta. That's right. It's a truth universally acknowledged in all math classes that any angle must be in 1/5 theta. Anybody know what I'm quoting right there? Come on, somebody's got to know. I heard Alex, yeah, I heard. Yeah, that kid's awesome. Okay, anyway. So, this would be sine would be 8 over 17. Cosine would be negative 15 over 17. I'll come back and do tangent in a second. So cosecant is just the flip of sine, so 17 over 8. Secant is just the flip of cosine. Now tangent is sine over cosine, right? Or you can just look at this and do opposite over adjacent, but it's the same thing. So it's 8 over 17 divided by negative 15 over 17, which I'm just going to go ahead and flip and multiply. Was it 8 over negative 15? And cotangent is going to be the flip of that. Negative 15 over 8. Good question, Emily. You're golden. Yep.
But it's only as long as you're raising it.
Yeah. Well, even if it wasn't. If I said, here's a random triangle. Sine of an angle of that triangle is 6/9. You can immediately draw the entire triangle. Because you know, let's just do that one I just said. If I said, here's a random triangle. Sine, here's theta. It's important to know it's right. If I said sine of theta, and I'm just making this up, was, actually let me choose one that's more, 3/5. If I said sine of theta was 3/5, that tells you the opposite was 3, the hypotenuse was 5, from SOHCAHTOA. You could use Pythagorean theorem to solve this for this side, and then 6 trig values, sine, cosine, tangent, by using SOHCAHTOA. Once you know one trig ratio, you know the whole triangle. That's why they exist. Opposite over, what's sine stand for? Opposite over hypotenuse. Yeah. And we're going to do one like that in just a second. This one didn't directly apply, but she asked me a separate question. This one's going to work the exact same way. Exact same way. Here's your cosine, here's your sine. Flip them to get your cosecant and secant, divide them to get your tangent. You don't even have to draw anything. Because it told you it's on the unit circle, that's cosine, that's sine. So what if it's not on the unit? Yes. Yes. In fact, it's funny you said 8 over 17. That's kind of crazy. All right. Notice, these directions do not tell you that it is a unit circle. So you cannot assume that the hypotenuse is 1. So this goes back to what Caitlin was saying. You have a right triangle. Doesn't matter how you draw it. And you know sine, oh, it actually gave me an angle. This is t. Sine of t equals opposite over hypotenuse, 8 over 17. Right there, you can find the third side and do Pythagorean, or and do your trig ratios, which I will do now. Of course, they gave you 2 just to spoon feed you, which was way too nice. Cosine of t, they said was the adjacent over the hypotenuse, so they told you this piece is 15. So I guess they're minimizing what you have to think about on each problem. So we need sine of t, cosine of t, which are already given, so I'm not even going to bother. Tangent of t, cosecant t, secant t, and cotangent of t. Let's see. So tangent, you could either look at your picture. Well, just look at your picture. Tangent, opposite over adjacent. 8 over 15. Cosecant is just the flip of sine. So 17 over 8. Secant is just the flip of cosine. So 17 over 15. And cotangent is just the flip of tangent. So it'd be 15 over 8. It's not. The only thing it's going to, I'll tell you right now, this is going to be one of those sections that it seems simple, but as soon as you start working by yourself, it's going to be like, oh, what do I do now? It's going to seem, because I'm jumping a little too quick. Try 27 on your own. Try 27 on your own. Well, no, they're given right here. Sine is 8 over 17. Cosine is 15 over 17. Try 27. I need all 4 other trig values. Well, I'm not going to bother with that. I'll pause this. Not expecting to have all those things read for about a week, by the way. I'm kind of a slow reader. Although I do look forward to reading all of them. The algebra is a little tricky on this one. What do you mean from the right angle? No, you always go from the angle you start with. Well, actually, this one they gave you sine and cosine, so if you wanted to think about it as just sine divided by cosine, that's something you could do as well. But it's all about how you drew it. You could have drawn it any way you wanted to. I'm going to put the answers on the board. Algebra is a little tricky, so we are going to go over it. Oh, I forgot. I promised. Mr. Jordan said he'd help me as many times as I ever needed to, but he made me promise that I will stop writing so much in black. Apparently it's bad for the something. Apparently it's like, no, like writing in black ink. He said it's like something about it's been proven that your generation responds better to colors or something. So I'm going to start writing in blue, in red. So this is how I chose to draw it. Here's my angle T. Sine, opposite over hypotenuse, 1 and 3. Cosine, adjacent over hypotenuse, so this will be 2 radical 2. If you chose to do it like this, there it is. Tangent. is either just opposite over adjacent, which I drew here, or you could have just done sine over cosine, which would have gotten you the same thing. I got that backwards. The only difference is 1 over 2 radical 2 is not rational. You need to multiply the top and bottom by radical 2. And that gets you radical 2 over, what's radical 2 times radical 2? It's 2, and then 2 times 2 is 4. So that's where that came from. Cosecant's just a flip of sine, or, you know, yeah, 1/3 flipped is 3. Secant was the flip of this, which rationalized extremely similar to tangent and got 3 radical 2 over 4. And then cotangent, you could just flip regular tangent, which was 2 radical 2 over 1 originally. Excuse me. Is this a trick question? How do I drink my root beer? No. No, just got my ice water here. Interesting. You know what then? I'm taking black off of my color palette. Won't even be an option. I've got orange. How about purple? We don't have a nice purple color. Pink. Okay. Whatever. Questions about where I got those? Please ask him if you got them. Ask me if you got them. If you couldn't just do sine over cosine, you'd take your triangle and do opposite over adjacent from SOHCAHTOA. Opposite over adjacent would need to be 1 over 2 radical 2. Yep. Alrighty. Really? Did I skip anything? Yes, I did. Okay. Alright. Now, when you do these later, don't bother reading. This sounds complicated. Basically, find the trig function, find the values of each trig function. So, eeny, meeny, miny, Josh, what is cosine of 5 or 6 on your unit circle? Radical 3 over 2. Now, there's 2 ways to do part B. Radical 3 over 2. There's 2 ways to do part B. You could either A, find a coterminal angle to negative pi over 6. Does anyone remember how to find a coterminal angle of the negative? Really? It has. Since it's Wednesday. You add 2 pi to it. You would just add 2 pi. Negative pi over 6 plus 12 pi over 6. Or, here's another way you can do it. Everybody put your finger on your unit circle on, let's see, here's your unit circle. Put your finger on pi over 6. Okay? And here's your x-axis, right? X-axis. Go the exact same distance. Instead of swinging it this way, swing it in the negative direction. And it's probably 11 pi over 6, because that's the same thing. What is cosine of that? What was it? Positive radical 3 over 2. They will not all be the same. It all depends on which trig function you're doing. But that's how you can find the negative. Just take the angle you went, and then just go the opposite direction, the same angle. And they should be symmetrical with each other across the x-axis. So, Brayton, what's sine of negative 5? I'm starting over. What is sine 5 pi over 6? I don't know. I'm not looking at it. What is? No, it shouldn't be. 1/2. That's okay. Cosecant. All right. So now for sine of negative 5 pi over 6, go the exact same distance except in the opposite direction. What's directly opposite of that? Negative 1/2. And same thing for tangent. Tangent of 5 pi over 3, you can find that on your own. Do the same thing, go to the other side of the axis. Same difference. Sine over cosine. Yeah, considering it's the last thing we did. Granted, it's been 5 days since I've taught you anything, but seriously, people. Okay, coterminal angles. Now this one doesn't need one, these two do. This is too big. It's not on the unit circle. Whenever something's too big, you need to subtract. So we need to subtract 2 pi. And no, common mistake, 9 pi over 4 minus 2 pi is not 7 pi over 4. Minus 2 pi, you have to put it in terms of a fraction, which you need a common denominator. So what do I need to multiply the top and bottom by? So the bottom is 4. I kind of just said it, didn't I? Which would give you what on top? 8. 2 pi times 4 is 8, so that'd be 8 pi over 4, which gives you what? 1 pi over 4? So what is cosine of 1 pi over 4? Radical 2 over 2. You'll do the same thing here, except instead of adding, you'll need, or subtracting, you'll need to add. So we'll add 8 pi over 4. Gives me negative pi over 4. That's still too low. Although, now that you've done that last slide, you could go and do it from here. Remember, just go to positive and go directly opposite for the negative. Or you could just add another 2 pi, and that would give you 7 pi over 4. And you could do it like that. That's negative. Negative. Oh. 9 minus 8. Oh, what is cosine of pi over 4 from a unit circle? Yeah. Yes, sir. Because these angles aren't on your unit circle. Because they're too big or too small. So you need to get in that range by just adding or subtracting. I'm going to call 47 through 51 bonus. You're right, it's not. So you'd either have to add it again, or just do the same thing we did on the previous slide. Go to the positive one and go directly opposite for the negative one. You have that option on number 41. Almost done. Here, this is kind of stupid the way they did this. Here's the thing. Every angle has infinitely many coterminal angles. Like pi over 2. You go around 2 pi, 5 pi over 2. 9 pi over 2, 13 pi over 2, and you could just keep going. Now, they gave you one of their coterminals. They're just getting you to notice all of these are going to be the same, these are going to be the same, these are going to be the same, because they're all coterminals for another. So it's kind of pointless. But nonetheless, to do this, you'll need to find cosine pi over 2, and then that exact same answer is going to be cosine of 9 pi over 2, because they're coterminal with each other. Raise your hand if when I say the word coterminal, you have no idea what I'm talking about. It's okay. Okay. Thank you for raising your hand. What I mean by that is, think of it in terms, it's easier when you think of it in degrees. You're at 30 degrees, right? Pick one over there. After you make one revolution, you've gone another 360, right? You were 30, plus that 360, now are you? 390. Another 360, 750, and so on and so forth. Same thing in radians. You started at pi over 2, and then you went 2 revolutions, or however many, and you got to 9 pi over 2. That's what I mean by coterminal. Same angle, just after a different number of revolutions.
Does it have to be less than 180 and
Less than 360 and less than 2 pi? It's preferred. Yeah. Well, instead of 360, what do I add to it? 2 pi. So pi over 2 plus 2 pi, which is pi over 2 plus 4 pi over 2, which is 5 pi over 2. That wasn't there. That's pi to go around again. 9 pi over 2. So it's that after 2 revolutions. Well, because it's the same as 360. Whenever it's radians, you'll use 2 pi instead of 360 for a revolution. Well, what's 53? What is sine 3 pi over 4? So would part B. Because they're the same angle, exactly. Just after another revolution. So that's, yeah. Okay. Questions? Sure. What is tangent of pi? Go over to tangent, take your sine, divide by your cosine. Pi is 180. It's on the left-hand side. No, there's a coordinate. It's negative 1, 0. See that? So that's sine over cosine. 0 over negative 1, 0. And 17 pi will be the same thing. That's after 8 revolutions. I think that's it for that one. Okay, these, just use your calculator. They just want to see that you can use your calculator. You didn't see a degree in the assignment all day, so please make sure you're in radian mode. And this is all you have to do. Turn it on, go to mode, make sure you are in radian, as I am. It's the default setting, so I bet you are. So, sine of 0.8, sine 0.8. Give me the decimal. What about cosecant of 1? There's no cosecant button, but cosecant is the flip of... I prefer a little bit more of a chorus there, but that's cool. Sine, so that's going to be 1 over sine of 1. Because it's cosecant, so it'll be 1 over sine of that value. Because inverse is not the same. Cosecant and sine inverse are not the same. They're those, never mind. Okay, cotangent of pi over 12, same thing. 1 divided by tangent, pi over 12. Boom. And there it is. All you have to do on those is plug them in the calculator. Okay. No. No. I know it seems like they should because we've learned that inverse means flip, but it's not. It's probably the most confused aspect of all of math is that correlation. Not the same. We'll go into it in the future. Okay, here you go. I'm going to make... Crikey, what numbers were they? Yes. 48 through 52 are bonus. 48 through 52 are a bonus.